So in this video then, I want to actually introduce you to the indirect proof technique. And like I did in conditional proof, I just want to show you how the process works, and then we'll talk about why it works. And so we're going to start with this problem. This is problem number 2 from 6.6. And just notice here in the instructions to this exercise set that we're actually told that we can use conditional or indirect proof, or in fact both techniques, in order to derive this conclusion, in this case, from these premises. So we actually do have a decision to make, conditional or indirect proof here. I want to let you know that on the exam on all of this material, there will be problems on their proofs where I'm saying, okay, use conditional proof on this one for sure, and use indirect proof on this one for sure, for example. But then also there will be problems on there where I might say, use conditional or indirect proof, and you have to decide which technique to use. So, having said all of that, let me just say that we would definitely want to use indirect proof on this one, simply because we could say there would be no obvious way as to how to start a conditional proof in this case, right? Remember from 6.5, conditional proof works very well when you have a conclusion that is a conditional statement. We don't have a conditional statement here, and so there would be no obvious way to set up, assume the antecedent in order to get the consequent. So instead, we're going to approach this with indirect proof. Once you have made the decision to do indirect proof, what you're going to do, like you do in conditional proof, is you're going to indent, right? But the assumption you're going to make here, and so you will make an assumption for indirect proof, and you can see here I've got another problem set up. I'll just move this a little bit there. We'll get to that one in a minute. But you're going to make an assumption for indirect proof, and the assumption you're going to make here is always going to be the opposite of whatever it is you're trying to get. So if we're trying to get n, we're going to assume tilde n. Okay? If you're trying to get n, assume the opposite, which as we see is tilde n. Again, I'll explain why once we get through this. Once we assume tilde n, just like in conditional proof, I try and use my assumption right away if I can, right? So in other words, I'm looking to use my assumption with any of the premises I have here. And of course, we have here in number 2, premise 2, an n. And so what we're looking at here is P, horseshoe, Q, and tilde Q. And I'm hoping that sounds like modus tollens. And when we do modus tollens, P, horseshoe, Q, and tilde Q, that gives us will give us tilde P, in other words, tilde R wedge M, right? Tilde P there. That's what we get out of modus tollens. Why did I do modus tollens? Because I could, right? Because it fit with our assumption. It allowed us to use our assumption, in this case with premise 2. Having done that, I'm going to keep going. I'm not going to worry about anything other than using my premises here first, as long as I can. I will note, though, just like we did in conditional proof, I encourage you to leave yourself a note here as to what you're trying to get. Well, the goal here in indirect proof is a little bit different, because you want to get a contradiction. So I've just written contra there. It might be a little hard to read, but I'm going to try and get a contradiction. I'm going to leave myself a note there. So we just saw again in the previous video, well, what is a contradiction? Remember, it's something, a dot, and then the same thing with a tilde in front of it. So we're going to be working our way through this, trying to get a contradiction. Now, having said that, I'm not going to worry about that right now because I haven't used my first premise. And so before I worry about getting a contradiction, I'll see if I can use that first premise. So looking at that first premise, we have an R in it, and we have an R down here. Can we get these to work together? Well, there's no obvious way to do that. But, so I would say I'm stuck, but I have tilde and wedge here, right? And so whenever I have tildes and wedges or tildes and dots, I will use De Morgan's here, lots and lots, in other words. And so I'm going to try De Morgan's on this, just because I'm stuck and I can use De Morgan's there. So when I recognize I have tildes and wedges, I'm going to use De Morgan's. And so I apply the tilde to both pieces, and I change the wedge to a dot. Now, that's a particularly good thing here, because I end up with a dot as the main operator, meaning I can simplify number 5, getting tilde R. Now I want to remember, I want to use line number 1 and, of course, line number 6 here. And I can. I've got P horseshoe Q and I've got tilde Q. So I can get modus tollens one and 6. Modus tollens 1 and 6 gives me all of that. So at this point, I have used all my premises. I've used my assumption. And so now I'm going to be hunting around for a contradiction if I can get it. Do I have a contradiction here? I don't. So do we have any of the pieces of a contradiction? Do we have like n somewhere and tilde n? No, we don't. So we're going to have to keep working. We're still stuck, in other words. So we have this. We boiled everything down to this. Can we use a replacement rule on this would be the question I would be asking myself. And the answer is yes. We don't have tildes and wedges or tildes and dots, but we have a horseshoe in here. And we know there are two replacement rules that will take a horseshoe and do something with it: transposition and material implication. Well, I don't like to use transposition unless I know that I want to flip the pieces around, because I'm still going to end up with a horseshoe there. So I'm going to just, since I'm just trying something, I'm going to use material implication here on line 7, giving me tilde K, wedge K, right? Material implication takes the horseshoe, turns it into a wedge, and adds a tilde to the left-hand side. Now, I want to emphasize here, because sometimes when people use replacement rules like material implication on a part of a line, they tend to get so focused on using it on that part of the line that the rest of the line might go away. So don't forget to carry down the parentheses here and the tilde. Don't forget to carry those down, just like so. So now do I have a contradiction? No, I don't. But I do have tildes and wedges, and that is a candidate for De Morgan's. And so when I do De Morgan's on line 7, I take that tilde and put it on both pieces here. So I add 1 to the tilde K, it ends up with 2. And then I change the wedge to a dot, as you see. It was something to do, right? I was stuck. I still didn't have a contradiction as of line 8, so I tried this. Can I now can I now recognize a contradiction is what I should be saying here. Do I have a contradiction here? In fact, I do. I know that for many people, they want to do double negation on these two tildes here to clean it up a bit. And if you wanted to do that, you certainly could, but it's not necessary. I have something, a dot, the same thing with a tilde in front of it. So this is a contradiction. And so when that happens in indirect proof, what do? You unindent, and the procedure here is always the same. Once you get your contradiction, you simply take your assumption and write it down and add a tilde to it. This is indirect proof, lines 3 through 9. Indirect proof, lines 3 through 9, right? All of these indented lines here. So this is the procedure. You made an assumption. You got a contradiction. You write down your assumption with a tilde in front of it, so we end up with 2 tildes here. And now finally, and I'm just going to have to squeeze this in here a little bit. Finally, if we want to match our conclusion, of course, which was n, at the very end here, we're going to do a double negation step to get that. Okay? So one thing to notice here is that in indirect proof, very often, the very last step you take will be double negation. So that is another difference here with conditional proof, right? In conditional proof, often you unindent and you write down the result and you're done. But here, pretty often, you have to do double negation as well to get this conclusion as it's written there. Now, that's the procedure. We'll practice indirect proof a few more times in these videos to make sure you're getting the hang of this. But let me just say here that the procedure is this, right? Going back to the original argument, or the thought process, I should say, is this. Going back to the original argument. Here's an argument. We know it's valid, right? We're told it's valid. We might recognize that it's a valid argument. But let's say somebody comes along and says, you know what? I don't think n follows from this. I don't think that n is a valid inference from these premises. And let's say you want to show them, well, that they're mistaken, that in fact n does follow from these premises. What you could do is this. You'd say, okay, might say it like this. Okay, smarty pants, right? You don't think n follows from this? Let's assume you're right. Let's assume n isn't true then, based on these premises. Let's assume n isn't true. That's what you think, I guess. Let's assume that. What happens? Well, when we assume n isn't true, we find, after several steps here, we find that you have to believe a contradiction. Double tilde k dot tilde k. Well, a contradiction cannot possibly be true. And this is a sure sign that something went wrong. And so what went wrong? We assumed tilde n was true, right? We assumed this. That is what led us to this contradiction. And so in logic, how do we say that can't be right? We add a tilde to it right down here in line 10. That's how we say this can't be right. We add a tilde to it, and in the end then, through double negation, we end up at the conclusion we were trying to derive all along. All right? So we'll practice this several more times, but that's the basic idea here behind indirect proof. We will just briefly, I'll just say, note that when we say get a contradiction here, and I do recommend leaving yourself a note like this so you remember what you're trying to do as you're working on this. That contradiction does not, of course, as we see here, have to be a contradiction with the assumption directly, right? In other words, you don't have to find n by assuming tilde n. Any contradiction will do as long as you're getting it from these premises and that assumption.